Today's podcast is focused on Goal 2 of the National Nanotechnology Initiative's 2021 Strategic Plan. That goal is to promote commercialization of nanotechnology research and development. I'm Mike Kiley, and I work at the National Nanotechnology Coordination Office, supporting efforts to achieve Goal 2. This podcast is one of many activities being conducted around the 20th anniversary of the signing of the 21st Century Nanotechnology R&D Act. Today, we're fortunate to be joined by Hunter McDaniel, CEO of Ubiquity out of Los Alamos, New Mexico. Ubiquity is developing a platform technology based on a class of nanomaterials called quantum dots. Hunter, thanks very much for joining the podcast this morning.
Yeah, happy to be here, and thanks for the opportunity. Just real briefly on myself, I studied electrical engineering and physics at University of California, Santa Barbara for my undergrad. And I kind of got the materials bug there and doing undergrad research in a quantum computing group. John Martinez was the professor. I just felt like it was the materials that enabled that really innovative research. And so I decided to get a PhD in material science engineering from University of Illinois. And that's where I got more focused on nano. My PhD thesis was titled Synthesis, Characterization, and Device Application of Nanocrystal Heterostructures. Kind of a mouthful. But that really queued up what turned into a great career in the company now in nano. But there was one step in between. After my PhD, I came to Los Alamos National Lab as a postdoc in the chemistry division to work with Viktor Klimov. He's a physicist that was exploring kind of the novel emergent physics that come from nanostructures. And that enabled me to kind of build upon the PhD thesis work I'd been doing in nano, and specifically nanocrystals, and maybe more specifically in quantum dots.
And Hunter, for our audience who may not be familiar, can you tell us what is a quantum dot?
Quantum dots are notorious for manipulating light. You can change the spectrum of light with very high efficiency. In the past, if you wanted to make a certain color of material, you had to create a new composition of matter, like a new phosphor material or a new dye molecule to make those colors. And fluorescence is a way of converting one color into another. You absorb light and then you emit that light. But the color of the fluorescence and the color of the absorption is an intrinsic property of the material. With nano, you can control these properties with size and shape now. So it gives you a new vector in materials optimization. And I think this was kind of the impetus behind all of the nano excitement back 20 years ago, was that it's a new paradigm, really, with materials innovation. And I'm very passionate about materials innovation in general.
And again, Hunter, sorry for interrupting. Can you tell us about your time at Los Alamos?
At that time, we had a CRADA with with a larger company, Sharp Corporation. They were interested in using nanocrystals for solar, and were pushing us to identify safer compounds, lower cost compounds than the legacy materials to enable commercialization. And right as I was finishing up my postdoc in 2014, Sharp was kind of having a difficult time in the market, and they had waived their right of first refusal to take a license to the technology. And I was also figuring out what I was going to do next. And I felt like it was almost my obligation to start the company to transition that technology into the marketplace. There were a couple aha moments that I had in the lab where I felt like we had really stumbled onto something important with these materials. And, I talked to Tech Transfer Office and, figured it out, kind of went to the School of Hard Knocks for an MBA, if you will, and started the company in 2014. Actually, yesterday was our 10th anniversary of the founding of Ubiquity. And sometimes I'm not sure whether I should be proud of that or embarrassed by it. 10 years is a long time.
Hey, Hunter, congratulations on your success and the anniversary of Ubiquity.
Yeah, we've come a long way since then. So Ubiquity is short for ubiquitous quantum dots. And the founding idea behind the company was that quantum dots have been limited by, first and foremost, their toxicity, but also their cost, and to a degree, the stability of these materials. And with this new composition of matter that we had identified at Los Alamos, actually it was first reported by MIT, and the company has a license to that, those patent filings. But we took it much further at Los Alamos. And the idea was that, now that we've addressed the toxicity issues, legacy quantum dots all were based on cadmium or lead. My PhD thesis, every paper I wrote had cadmium in it. And so we had identified a copper and zinc-based version of quantum dots. And the idea was that now they can literally become ubiquitous. They'll be widely used in many applications beyond kind of the beachhead market and display. And that was the founding idea of the company, is that we've unlocked all of this potential of quantum dots with this new composition of matter. And that's where the name of the company comes from. But it was a very slow go at first. I was by myself for the first almost 2 years of the company, just trying to figure out how to fund things, how to run a business, really, trying to surround myself with smart people that had experience. And what really got things going actually was an SBIR that we got from the National Science Foundation. I believe we got that in 2000, maybe got the award letter in 2015. And that's where I was able to go and start to hire people. And so I hired my first employee in late 2015, and then the second one in 2016. We built upon that. And since then, we've had a number of federal awards. We have about 30 employees right now. We'll do about 4.5 million or so, maybe 5 million in revenue this year. We've raised about $11 million. We have multiple products on the market. We serve a couple different industries with our quantum dots. I would just describe us as one of the leading companies in nano and in quantum dots specifically. There's only a few companies in the world that actually manufacture quantum dots. And we're, by my measure, about the third largest. The other two are in Japan and Korea. So, I feel like part of our role is to develop this technology in this industry here domestically, given that this was first and foremost funded by US taxpayers. And I think there's a lot of potential to establish a supply chain here. So that's kind of our role. We're quantum dot manufacturing company, but we go downstream in some application areas to develop in products that are enabled by these materials.
And Hunter, how do quantum dots enable the materials that you're discussing?
So we manipulate spectrum of light, and where the company has focused is in manipulation of sunlight. We do have some application areas that don't involve sunlight, but our first product line is in agriculture. We make a greenhouse film that shifts the spectrum of sunlight to be more red. Red photons are absorbed the strongest by plants. That's sort of why they're green. They don't absorb green light as strongly. They mostly absorb red and blue. So if you can give a plant more red photons, they'll absorb those photons and be more effective in their crop growth. It started off as an idea a number of years ago, but we have since proven that out, and we have 6 or so products on the market. We just launched a new one in November, basically variations of incorporating fluorescent quantum dots into greenhouse facades.
So Hunter, tell us about partnerships that you and Ubiquity have been trying to form.
Recently, we announced in August a partnership with First Solar. They're the largest solar manufacturer, module manufacturer in the world by market cap. They do about 25 gigawatts a year. They have a similar sort of issue with spectrum where they're not utilizing the full spectrum of sunlight like plants do, at least not as efficiently as they could. And so if you can use these materials to shift the spectrum of sunlight, you can improve the efficiency of a module, solar module. And so that's a big activity now at the company. And we've been working on that for about 2 years with First Solar, but we just announced the partnership in August, and that's going really well. It's very similar to the greenhouse stuff, but instead of helping plants, we're helping a solar module. A couple other interesting ones. We have a partnership on security inks, anti-counterfeit, with a large Swiss company that makes inks for all the major currencies and other kinds of products. They're in the US currency, they're in the euro, Swiss franc, the Aussie dollar, and they're interested in using quantum dots to basically fight counterfeiting, create a unique optical effect. There are a host of other use cases that are kind of lower level. Some people want to use quantum dots for cosmetics. They want to use them for art and design. You can use them in windows in different ways to improve the kind of energy efficiency of a window. So it really is a platform technology, a specialty chemical, if you will, or an advanced material that's at the core. And we serve I view it as an important role in manufacturing those materials, but we also collaborate with folks on how to use them and deploy them into products.
Since you mentioned the SBIR process through NSF, could you tell us what your experience has been in competing for those awards and then executing them?
The advice I usually give founders around resources is that you should start with customers and partners. If you're solving a problem that they have, then they should be compelled to provide resources to you. And it might be the easiest path to getting resources. Then next, I would say federal funding or grants. And that is really how it played out for us. We started off with with a partnership, and then we got into NSF. It was a phase 1 SBIR. We got to the phase 2, and then we tapped the kind of the extension programs. They have a commercialization one, and then they have a matching funding thing with investors. And that was focused on a window application, actually. In those early days, we thought that Windows was going to be the ultimate application. And we are still working on that today, even though those contracts with NSF ended some years ago. Since then, we've also had, we had a phase 1 with DOE on lighting. We had a phase one and a phase two with the U.S. Air Force, also on Windows. We've deployed some solar windows on a U.S. Air Force base in South Dakota. And then very recently, we won a USDA phase one to develop a glass version of our greenhouse product. And we haven't started it yet. We got the award, basically notification of sort of negotiation that we had been sort of selected in, I think it was December, but it's not supposed to be funded until like July. So we're going through the motions now on getting that to kind of closure, but we'll have a USDA one starting up soon.
When you try to raise money from other sources, non-government sources, has having SBIRs, help make your case that your company has been vetted by the government and is a reasonable partner for somebody else to invest in?
Yeah, it helps. The non-dilutive funding is something that a lot of investors like to see. It can be a double-edged sword. There are investors that see it as a negative, that, the overhead, the burden of kind of being compliant with it, and potentially it can take you in a different direction than what the market wants. Because you're not necessarily being vetted by customers in that process. You're being vetted by, there's a peer review and then the administrators. But I think most investors view it positively. And I mean, even separate from that, it helps keep the lights on. I mean, that funding is very potent because you don't really have to give up anything for it. I mean, there are some rights that the government gets to any IP created, but for the most part, there's deliverables depending on the type of contract. You may have to deliver prototypes or technical reports and things like that. But you don't have to give up equity. You don't have to deliver, like a product with some sort of guarantee that it's going to work, like you might have to do for a customer. So it's very, very potent funding, and I think most investors view it favorably.
That's a great explanation from somebody who's on the ground trying to build a company with the help of the government. The government has an active lab-to-market effort aimed at getting the products of federally funded research into the private sector. Have you tried to out-license technologies from a federal lab?
Yeah, absolutely. That's kind of the founding, moment of the company, really. I was at Los Alamos as a postdoc. I was an inventor on a number of patents. In fact, one of the patents I'm the sole inventor on that's owned by basically the contractor that manages Los Alamos National Laboratory. And so we have a license to those patents exclusively. We also took a license to patent family from MIT, which when I started the company, I was just sort of doing my diligence to make sure that, I had freedom to operate, if you will. And I was aware of a paper that came out of MIT, but I hadn't been aware of the patent. I reached out to them and it was available. So we took that license. So it's kind of a long process there. And then we're also licensing some IP from University of Washington. That happens to be related to the window technology that I mentioned earlier.
Besides lab to market, the federal government has a lot of programs and resources for companies to use, user facilities, CRADAs, et cetera. Has Ubiquity access to any of this stuff? Have you used federal labs or out-licensed or used CRADA?
Yeah, well, and I mentioned earlier that we were kind of spun out of a CRADA, if you will, at Los Alamos that Sharp Corporation had with Los Alamos National Laboratory. At Ubiquity, we have tapped some support specifically from NREL in Colorado, Los Alamos National Laboratory here in town, and they're literally a stone's throw away. So we're very close to them physically. And then Sandia, which is in Albuquerque, about 2 hours drive south of here. Those are enabled uniquely by some programs. So one of the challenges of working with national labs is the overhead rate is very high, and it's hard to it's hard to justify spending that kind of an overhead rate when you could just sort of hire people and do the work yourself, or maybe work with the university where the overhead rate is much lower. And the way that gets mitigated, or one way it can be mitigated, is with sort of these programs. And for example, we did the small business voucher pilot program that was funded by the DOE with NREL. And then we've done with Sandia and Los Alamos National Laboratory, there's some state programs that provide incentives for the lab to help small business. Basically, it's a tax break, and that eliminates the overhead. So you get much more potent spending, if you can leverage that. And it's called the New Mexico Small Business Assistance Program, NMSBA. And I think that's a great model for, what we could potentially be doing across the entire nation. And then more recently, they started what's called the Trigger, TRGR, Technology Gross Receipts Program. The NMSBA is, I think, $40,000, but it's unburdened of support annually that the lab will provide to companies. And we've done that maybe 5 years. And then 1 year with Sandia. And then the Trigger, I think, goes up to 150,000 or maybe 200,000, also unburdened. But in order to be eligible for that, you have to have a license with the lab. And we do have that IP license, so we're eligible for that. And we've used those programs in a surgical way. Basically, you get access to expertise at the labs, you get access to equipment, and they'll kind of run a project for you, with a time bound and a budget bound project. But it's been very helpful for us to be able to collaborate with those labs.
Well, thanks for that. Let me just ask you one last question about your business and where you see the landscape. Everybody's competing for talent. What kind of comments would you make along the lines of the war for technical talent, or, keeping talent home, or community colleges or technical colleges, and how you see that from the ground?
Yeah, I mean, it's challenging in general. There's a lot of competition for talent, and especially during COVID, salaries really escalated, and everyone kind of expected to be able to work from home. We are a hardware company, a technology hardware company, so we generally need our people to be on staff. So that's been something that's been tough, that we can't offer work from home options as much as maybe other companies. But we have some unique challenges being here close to Los Alamos and Sandia, given that the national labs also have a lot of funding and they have escalated salaries to be able to compete as well. And so it's been difficult to keep up with just the salaries that they offer. So we've lost some employees to the national labs. We've also gained some employees from the national labs, so it goes both ways. But it's difficult to compete on salary alone. So we try to make up for that with the aspect that it's a fun place to work and that it's, having an impact and all that. But I mean, in terms of compensation, we offer stock options. We offer very kind of generous paid time off. We're very flexible. We do a lot of team building. Like last Friday, we had a team building day up at Taos Ski Area, at company ski day. Last night, there were about 10 of us celebrating our 10th anniversary at a local pub and stuff. So it's a fun place to work where we have kind of generous sort of work-life balance opportunities and equity. Another aspect of it is just the workforce in these sort of technical degrees, like PhD material science, like I have, often are weighted in with immigrants. It just happens to be that way, that there's a lot of folks that come over from overseas to get their education here. And so we're out there hiring, and those folks are applying for jobs, and they look very, very good, and they're highly skilled. But it's challenging for a small company like ours to be able to navigate the immigration side of things. Typically, there's a short fuse, a couple of years, where they're allowed to work in the U.S., and then they have to figure out what's next. And for a small company like ours, it's difficult because we don't have the lawyers, we don't have the experience to be able to help them transition into a more longer-term immigration status. So that's something that we've struggled with. Over time, we've gained some experience, and we have several foreign nationals here at the company, and some have actually successfully transitioned to green card or actually U.S. citizens. We have a couple that have actually become U.S. citizens. So yeah, I'm optimistic about the future, and we've been successful in getting great applicants and recruiting good people. So
that's good stuff. I'd like to thank Hunter McDaniel of Ubiquity for sharing his time. For those looking for more information on Hunter or Ubiquity, go to www.ubiquity.com, spelled UBIQD. And for those interested in more information about the NNI, the National Nanotechnology Initiative, go to www.nano.gov. Thanks for listening. There'll be more conversations with thought leaders and CEOs in the future.